Good afternoon and welcome. I hope you've had some fun time. My name is Paula Ingabire. I'm a second-year student in the System Design and Management program. I have the pleasure this afternoon of introducing our next keynote speaker, Professor Dava Newman. Professor Dava Newman is the Apollo Program Professor for the Astronautics and Engineering Systems at MIT. For the past 25 years, Professor Newman has been a faculty member of the Aeronautics and Astronautics Department at MIT's School of Engineering. She serves on the Harvard MIT Health Sciences and Technology as a faculty member, as well as the Mark Vicker faculty as a fellow. Professor Newman received her PhD in aerospace biomedical engineering from MIT. From 2003 to 2015, she served as the Director of Technology and Policy Program. In addition, Professor Newman served as the Deputy Administrator of NASA from 2015 to January 2017. Professor Newman is the author of Interactive Aerospace Engineering and Design, an introductory engineering book that was published in 2002. She has also published more than 300 papers and journals. Her expertise is in multidisciplinary research that combines aerospace biomedical engineering, human-in-the-loop modeling, biomechanics, human interface technology, life sciences, systems analysis, design, and policy. Her research studies are carried out through spaceflight experiments, ground-based simulations, and mathematical modeling. In addition to her space research and saving the Earth, she has also ongoing efforts in assistive technologies to augment human performance here on Earth. So buckle up, and as we enjoy our ride to space, please join me in welcoming Professor Newman to deliver her keynote address on developing an innovation framework for NASA. Welcome.
Thank you. Hello, everyone. Good afternoon. Good, you can hear me well? Well, I'm thrilled to be here. Hope you're having a great conference, and let's get started. With your permission, I'll take you around the solar system a bit. So for exploration, we have three fundamental questions, all of our exploring, with all of our rovers and orbiters and human spaceflight, which is my specialty. Number one, are we alone? Number two, are there other habitable planets? What about life? All of our exploring in space, and I would even submit oceans, are really around these three questions. The evidence is mounting. I'll try to convince you that think the data is really compelling. My prediction is that probably we'll find life in the next decade. Now, it might be past life, and we'll walk through that. But these are the overall guidelines. This is a beautiful image from Hubble. Who's 28 years or younger? Hope there's some students in here, right? Well, your entire lifetimes, Hubble's been searching, peering back, trying to figure out where we come from, where we've been, and then it's our job to think about where we're going. But we're trying to find out, the last 13, 14 billion years of existence. So again, if you're 28 years, Hubble last week, actually, last Tuesday, Hubble was launched 28 years ago. And it's been amazing science. So get ready for what's next. When I was fortunate to serve in the Obama administration as a NASA deputy, right when I landed, we had the New Horizons mission. Well, space missions take, some investigators worked on this for 30 years. Funding, no funding, funding, no funding each decade. And then finally, you get to Pluto. Finally, we had gotten to all the planets. I count Pluto. I know it's a dwarf planet, but I was kind of a dwarf basketball player in college myself. And we didn't know what Pluto looked like. So when we zoomed in on it and could really now measure Pluto, looking at its moon, almost the same size, really revealing the mystery of planet formation and close in our solar system. So now we know the chemical constituency, we know the topography of Pluto from this amazing New Horizons mission. Next up, Jupiter. Today, we're in orbit around Jupiter. And Jupiter is an incredible planet to study if you want to know about our solar system and the formation of planets, because all the rest of our planets could fit right inside Jupiter. And this is a really hairy mission as well, the world's largest solar-powered, we're really off the grid here, solar-powered spacecraft, Juno, the goddess of Jupiter. is there today. We're in this, if you can see the top right, we're in this very hairy polar orbit because the radiation environment of Jupiter is 20 million times that of Earth. You know, these are real extreme environments. We shield all of the scientific instruments in a half inch, you know, over about 5 millimeters of titanium casing, just so we can keep our instruments working. We're 2 years now at Jupiter, just coming to close to the end of this mission, investigating. And for the folks down here in front, I'll draw your attention to the bottom right image of Jupiter. It's my favorite camera on board Juno, and it's called the Juno Cam, and it's citizen science. I think you probably all know citizen science, open up to the world. Hey world, come with us to Jupiter. You're on the mission as well. So we let the public, they just hop on the NASA website and they get to point the Juno Cam, and this was an image taken with someone said, I want to look at Jupiter and I want to study that red spot. That red spot is a 300-year-old storm still raging, and to scale, I've superimposed Earth, just so we can kind of think of our scale and place in the universe, but even in the solar system. That's Earth to scale, you know, on a picture of Jupiter that was just taken from a curious person saying, you know, I do want to come on the mission with you. Again, opening up science and exploration to everybody. Okay, well, as promised, I want to tell you a little bit about kind of put some of my own research and then some of the larger NASA portfolio into an innovation framework. Thought that'd be the most interesting for you all to hear about. There's lots of innovation at NASA, but first I thought I could maybe do a strategy. Well, that was an overstep, and said, okay, well, how can I empower innovation? How can we bubble it up and not just have 1,000 flowers blooming and innovation all over? How do we really put a framework around it? So this is what we came up with. I'll walk you through this in terms of continuous innovation. Probably 80% of innovation is just, you know, going to work every day and saying, what am I going to do great today? Continuous improvement, doing something better with our technologies as a technologist myself, or business practices and business model. And then we move over to the left, in what I call disruptive innovation, is where you would change your business model. For us at NASA, it was change the organizational model. What can we do different to change the organizational model? Pretty much with the same technology. And move over to the right to what I call revolutionary innovation is, okay, what's the revolutionary technology, the big push in the technology with our existing business and organization models? At top, that's really hard. That's what I call transformative innovation. Here's a nicer picture of the same words I'm walking through. Transformative innovation. We need the new revolutionary technology, and we need the new business model, and we need them together. So we're going to transform the business model and the technology. So that's hard. That's hard to do, both at the same time. Well, I want to give you some examples, and mostly it was trying to make our environment and our culture at NASA the yes zone. Said all ideas are great ideas. So it was kind of like the innovation idea portal. What ideas do you have? And fundamentally not letting anyone say no. Saying yes, all ideas are good. Now, we have constraints. Maybe we can fund them, maybe we can't. But wanting to get all those ideas in the portal, and then can we really have a portfolio, figure out, you know, really what we could fund and not. And there's different colors here, but you see, again, the weight really to the continuous innovation to do that, and then kind of equal weight to the revolutionary and disruptive, and then those big bets on transforming and really looking out much longer term to some very big missions. So I'll give you some highlights of all of these categories. So we benchmarked, we looked all across the agency, and just on the right, just came up with a whole bunch of promising practices, actually over 100 promising practices, but no one knew about it. Maybe only people knew at their space, you know, the NASA Space Center, Johnson Space Center in Houston, or maybe they only knew about Langley. So again, we really needed to make this portal and kind of collect some of these promising practices so we could try to scale it and do this much more across the agency. So got together the 40 top leaders of NASA. NASA is about just under 18,000 people. If you don't know about that, then we have about 75,000 contractors. But just getting together those 40 top leaders from across all of our NASA centers and headquarters, and you know, stickies and saying, where's innovation? What can we do about innovation? Getting these best practices. What do you have a good idea for today, but you can't get done? That was a really important question. And so these, again, are just some great ideas. You can read through them, you know, from hackathons to SwampWorks at Kennedy Space Center, having a place where people can go multidisciplinary and really work on some of their great ideas. Just the incentives and rewards to employees as well. Again, raise them up across the agency, raise everybody up. So we had an innovation day. And guess what? It was run by what we call our firsters, which is early career folks. We gave them, you know, of course, they're the best ones to put in charge. And so, you know, to put on an innovation day across the agency, and it wasn't, turned out, Innovation Day turned out to be 3 days. You know, again, Kennedy Space Center, 2 days at Johnson Space Center, and kind of putting them in charge and say, you go out and look, bring everyone's ideas, and then again, some rewards, some monetary, but mostly just saying, yes, go forward, and some resources for these crazy ideas that everyone has, but didn't fit in to the normal process, you know, and incremental work that we go through. So I want to highlight some more of these blue sky events. I'm in continuous innovation now, just again, doing great things every day. How do we empower that? There's great ideas. We were able to celebrate 100 years of NASA Langley, our aeronautics research center. And supersonic flight is coming to you, and it's coming to you hopefully within the next decade. The hybrid human-machine interface, you can see here, I specialize in astronaut performance and the biomedical aspects of human performance, and then again, computational simulations that again are very much 10 times more powerful than we've had before. So again, just some blue ideas. It's hard to think about the next 100 years. It's really hard, even with great students around here. I went to 10 years maybe, but 50 years and 100 years out, those are usually pretty crazy ideas. And of course, we never get it right, but I'd submit that the exercise helps people really continue to be innovative and think that all these ideas are welcomed and we have the opportunity to share them. So I want to tell you about some of my work in terms of articulating, coming up with a strategy to Mars for human exploration. We have to get a little closer into the solar system when we talk about human exploration. And so we rolled out our Journey to Mars to answer the questions. NASA doesn't have a strategy. Yes, we do. Mars is the horizon goal. It's the horizon goal. It's really hard. It's really far. So 3 phases. Mercury, Gemini, and Apollo. I'm here today, kind of a space nerd and passionate, I think, because the Apollo program. So it really was a 3-phase plan too. Earth, meaning low Earth orbit on the International Space Station. I'll highlight some of the accomplishments there. Again, kind of continuous innovation and great work going on in science and technology. The moon, now with the new administration too, the moon is definitely the next step in terms of a little harder. We have to get more technology. And then Mars, keeping Mars as the horizon goal, because we can't get to Mars today with humans. We've been there the last 50 years with our rovers and landers, which I'll show you coming up. But 3 phases. Again, low Earth orbit, getting out of low Earth orbit, because we've been stuck there for 40 years, getting to the moon. We call that deep space, further than any humans have ever gone in deep space. And then 3rd phase, getting to Mars. So the 2020s is really the lunar exploration with humans and machines, and the 2030s and beyond then too, seeing if we can push it to Mars. So here we are in Space Station. I don't think anyone's 17 or younger in the audience, but if you were, every day of your life, so it's your younger siblings at home or your sons and daughters at home, we've been living multinationally on International Space Station. There's 5 main partners, NASA and Russia and Japan and Canada, and then the European Space Agency, which is 23 nations now, so that's a lot. So 5 main partners, but 95 nations have been with us up on Space Station, investigating, doing experiments. So it really is, I think, the best example we have right now for global, for international cooperation to get this done over the last 2 decades, and we're going strong. We'll be going strong probably till 2025. Now we have to think about what technologies, what science can we do today living off Earth, for the Earth, but that also help us with that destination of getting to Mars. So I asked Scott Cully, you probably know of Scott, he spent 1 year up on Space Station, so I asked him what technology to invest in, what innovations are needed, you know, to really realize this future of human spaceflight, and here's what he told me.
Yeah, I think the life support systems that we need to keep us alive in space are ideal candidates for demonstrations for our future journey to Mars, as well as space suits. We need, I think, new spacesuit technology that you know, requires less maintenance in space, and you know, something that's going to be easier to work in on the surface under the Martian gravity.
So you might know I'm a spacesuit researcher, so maybe it was a loaded question, but life support and things. We have incremental technology going on right now, just in that continuous in our life support systems. You know, your oxygen, scrubbing out the carbon dioxide, your humidity control. That's not good enough for our next 2 steps. We need really very different life support technology, suit technology, and probably bioregenerative technology when we really get to Mars, to the next planet. So again, these technology investments, we can really realize these missions. And there's nothing like fresh food anywhere, but definitely when we're locked up on our boat sailing or when you're locked up in International Space Station. So they're celebrating and we're growing vegetables. They're have some lettuce growing there, lettuce and cabbage. It's not so much for the nutritional value, is to understand, this is what we call our Veggie 3 experiment. How do we really grow and harvest? But the psychological aspect of that is really important. It's about the plants and life support, but people and seeing living things and growing living things is really, really critically important. Now, this is a 6-month missions on Space Station. Scott and Mikhail Kornienko, his partner, spent 1 year. Mars mission is 3.5 years. 8 months out, about 1.5 years to get home, so a couple years just for the orbital mechanics round trip, and you're gonna spend 500 or 600 days on the surface because we're looking for life. So now who wants to sign up for my Mars mission? I still usually get some volunteers, come on. So thank you, Brian. You know, all the students still want to. But that's what we're looking at, you know, so we've done a successful one-year mission, you know, with 2 crew. This is, again, highlighting Scott's mission. It was the first time we could do genomics. It was pretty exciting for us. It really revolutionized how we were doing, looking at the human body, the space life sciences aspect. Scott has an identical twin brother, Mark, a former astronaut as well, as you might know. So then genetically we ran what we call the twin study. The papers are just being published today. But you're gonna lose 30% of your muscle atrophy. You're gonna lose about 40% muscle strength. That's the good news. You're gonna lose about 1 to 2% bone mineral density. You know, your structure and skeleton, because you're floating around, you're exercising like crazy, a couple hours a day, but we still have a lot of musculoskeletal loss. So what countermeasures can we look at when we look at the human body and all the systems together? So we're getting better. We look at these countermeasures, but again, we have a long way to go still. Make sure our astronauts are healthy. Radiation is a huge, important issue for a Mars mission, and even deep space. Of course, we're protected in low Earth orbit, so now we have to worry about radiation for our Moon and Mars missions. Those are just some of the top things we look at when we look at the astronaut performance and how to keep them well and safe in our long-term missions. Okay, so I want to take you to Mars. That's my passion. Again, 3 phases: International Space Station, getting back to the Moon, and then Mars. But I put this in for historical reasons because it's the 50 years humanity that we've already been exploring Mars. So I want to do a quick review for you. I think you'll like it.
On your preliminary analysis of this data, can you describe what you see on Mars?
Yes, it's there.
Oh, I'm only showing you the successes. It's really hard to land on Mars. 3 gravity environment, 1% atmosphere. We know there's ice, water ice on the North and South Pole. We've landed every which way we can. Here's airbags. You might remember Pathfinder. It's all about the people and the engineering and the technology, and I'd say the innovation that goes into it. Another landing system, retro-rocket propulsion and airbags.
The rover has landed base metal down, which means
Deployable
right side up.
structures. MRO is still in orbit today, giving us data. Phoenix lander, articulating, structural landing legs. Retro rockets.
27 meters, 20 meters, 60 meters, standing by for touchdown.
You nail a landing, and people have been working on this their entire careers. It feels pretty good. And here's Curiosity, the most complicated structure landing
Led by the
crane that we've ever
extraordinary men and women of NASA. NASA in our Jet Propulsion Laboratory. Right now, the wheels of curiosity have begun to
I
blaze
had
the
the great
trail for
pleasure to
human
serve under
footprints
Charlie
on
Bolden
Mars.
as administrator.
I just wanted to call and say congratulations
Both had great
to the
support
entire Mars Science
from
Laboratory
President and
team
Science
really
Advisor
all
John
of
Holder for
JPL.
Science,
You guys
Technology,
should be
Innovation.
remarkably proud.
We still have Maven in orbit. I'm going to show you some data from Maven orbiting, mapping the atmosphere. And that's the next big rover coming. It's Mars 2020. We're going to make oxygen on the surface of Mars. But that's what I spend all my time thinking about, pushing it for at least the next, hopefully, 10, 15 years so we can get humans on Mars. It's challenging. Oh, good. You guys are a great audience. You clap. I told you I only showed you the successes in the video. Here's truth in advertising. I gave an award at NASA called Fail Smart. So this is human history trying to get to Mars, because Mars is really far away, it's really hard. So since the 1960s, the Soviet Union and the US, we've all been trying to get there, just to fly by. Can we do it? Can we orbit and then land? And take a look at those green checks that I've kind of highlighted here. We have 7 assets on Mars today. NASA has 5. The Indian Space Agency has MOM. I love that acronym. It's the Mars Observer mission. And ExoMars, it's the European mission, and it was launched on a Russian launcher. So what we say is that anyone's success is our success. For all those missions, NASA and the US, we give the Deep Space Network. We work on navigation and control. We want everyone to succeed. And next up, it's United Arab Emirates. They're going to send a probe called HOPE. I sure hope they make it. You know, it's hope for the world. It's hope for all of us. We're all in this together. Again, it really is global exploration. Just can't say enough about, never saves you money, and usually doesn't save you time. But I think it's absolutely the right way to go about in terms of these models that are kind of global models and letting everyone participate and bring their expertise to the table. So here's some of the latest scientific discoveries on Mars. On the left, you'll actually see this changing. When we go to search for life in the universe, we say, look for the water. So we know that there's ice in North and South Pole, but now we actually know that there's seasonal fluid, water, much more equatorial on the left. It's high salinity, very briny. You can't drink it yet. It'd kill you. But that's phenomenal, that it's not just water trapped in ice, that we actually see the fluid flows down. We think that Mars probably had life. It was probably warm, wonderful climate 3.5 billion years ago. Earth and Mars are 4.5 billion years old each. So what went terribly wrong? If Mars lost its atmosphere, lost its life 3.5 billion years ago. This is from the Maven spacecraft looking at the atmosphere, and some of the first data really conclusively is how did Mars lose its atmosphere? Well, it doesn't have a global magnetic shield. Lucky for Earth, we do. And life's worked out pretty well here. But Mars today is 1% carbon dioxide atmosphere, and in that animation, you literally saw the sun's wind and radiation obliterating, since the ionization of the Mars atmosphere that we're seeing in that simulation from our latest Maven data. So helping us understand how planets lose atmospheres in space. We could talk about Venus, we could talk about a whole bunch of planets in terms of what we know about their climate, their atmosphere, and again, over the long term, over billions of years of evolution. Okay, so we have a whole bunch of technologies mapped out here. I just put them in pictures. But in order to get there, again, we'll keep doing the rovers, but in order to get people there, we have a lot to work on. I can't reiterate how challenging Mars is. It raises us up to our best. But entry, descent, and landing in that low Mars atmosphere is terrible, because it's just enough it doesn't really slow you down, but it's just enough to heat you up. And we've had success at landing 1 to 2 metric tons. Human missions, 10, 20 metric tons. We don't know how to do that, So we have to test. We have to design new systems. We have to learn how to live off the land. All of successful exploration in human history, we call that in situ resource utilization. I give my students the challenge. We have to make the maker on Mars. We don't get to bring it with us. We don't have anything there. I have one rover, right? And some small previous rovers. So we don't have that mass. So those are just some examples of kind of all the technologies I already mentioned, life support previously, that we really need to work on before we can do it. And we need to integrate the science as well as the exploration as well. Okay, so moving on a little bit in the theme of the innovation to this model, then this framework. What about changing your business model? For us at NASA, it was the organizational. And again, best practices, trying to look at those and bubble those up and share those across the agency and with folks. So I'll give you a few examples. This one we're really, really proud of. the public-private partnerships. So private, of course, has always been in cooperation with the government, but we're very explicitly saying, you know what, for International Space Station, NASA doesn't need to own all that, doesn't need to have all the systems. That we're going to buy services. So let's buy services from industry because I can do it probably more efficiently and keep it going, and it's good for the economy. And that test, again, that test is really working. See, orbital ATK, they'll be the next to launch cargo up to space station. See, SpaceX, they've both been very successful. They had some failures, right? Failures we learn a lot from. You have to fail. This is rocket science. You're not going to get it right every time. And then down on the bottom, the international partners, the Russians and the Japanese cargo vehicle. Again, we're all in this together, everyone working together, and really looking at those public-private partnerships in quite a different way. A lot of them are fixed-price contracting, and then again, working really hand in hand. We have NASA folks at the industry and industry folks vice versa. We want everyone to succeed. We have to fight really hard, with Congress and folks say, no, not just one supplier. We're putting our bets across. We want to, put our bets across the industry. Next up is actually with humans. The next, bringing humans to the space station. They're testing in 2018. That'll happen in 2019. And Boeing's under contract, SpaceX is under contract, and now Sierra Nevada Corporation is the third for cargo. So again, spreading those contracts around, working with the private folks. I put global exploration and innovation here too. The world really is in this together. There's something called the Global Exploration Roadmap that we all agree on. There's even more now space agencies from around the world. And again, at the innovation side of just how can we do it different? What models do we know? What are the new and best innovative models that we can really globally get this done? And leadership from all over. And then Mars 2020 rover, just to highlight some of the international experiments and science on there. And then in the bottom left, taking a look at the James Webb Space Telescope, which is, we looked at Hubble to start my talk. Well, James Webb now is 100 times more powerful than Hubble. To be launched in 2020, the world's most glorious observatory with 18 articulating beryllium gold-plated mirrors. It's in the infrared, whereas Hubble is in the optical. So we couldn't predict what Hubble would tell us. We definitely can't predict what James Webb will bring us. Again, searching back to look for, past the Big Bang, really, going back 13.5 billion years to take a look at the formations. So that's kind of what's still innovative, what's coming together on major programs. And I want to show you the Space Launch System is the next heavy lift launch vehicle. This is investing in 1,000 companies in the U.S. to get back to the moon. Get back to the moon, get to deep space, get in lunar orbit. Keep fingers crossed, we'll fly next year. Probably gonna slip from 18 to 19. First launch, we call it Exploration Mission 1, which is what this video is of. The engines are tested, the solids have been tested. It's huge, it's more powerful than Saturn V. It's been 40 years since we've had this much development going on. That's the real hardware. This is animation. That's the real hardware. That's the Orion capsule. That's the capsule that's on top that'll house the crew. There's actually 2 copies of Orion already delivered to the Kennedy Space Center in Florida. That's entry, descent, and landing. I mentioned before, coming in hot, we have to test it. We have to test it everywhere we go so we can improve our techniques and understanding. Test again when it comes to real spaceflight hardware. You want to make sure it works when you get there. So it's Boeing's rocket space launch system with the Lockheed's Orion capsule on top with the European service module as the ring. So we're incredibly excited about that. And then to also give credit where credit's due, and SpaceX has its heavy lift, had a wonderful first test of its heavy lift. And Blue Origin, keep tuned, keep your eyes on them. The BE-4 engines are very sweet. Sweet, sweet, and the world needs them. So just can't wait. But again, just great examples of, we haven't had heavy lift launch in over 4 decades. What if we have 3 heavy lift launch? Again, for the world. And I don't even have time to talk about all the great things going on in Japan, India, and China with a whole bunch of capability for the world. We're gonna have hundreds and thousands of people, especially in low Earth orbit, coming to you soon. Okay, let's talk a little bit more about technology and innovation, which I call, again, revolutionary technology. What if you really want to do the technology pushes? And again, just a sample, I've mentioned a few of these already. I am an aerospace engineer, so I want to give you a picture at least of airplanes and tell you, again, I was kind of taught aeronautics and then space engineering, and now I say we got that wrong because it's just a whole continuum. And the really exciting stuff you see up top, that's a supersonic. That's a new supersonic jet that has been funded in terms of the demonstrations. And the amount of traveling that I know we all do in this room, wouldn't that be great to cut the time down by half? We'd all love that because we can get the boom down. It's a supersonic but low boom demonstrator. Can't break windows. It can't disrupt communities. So now it's kind of like a thump. It's like a thump rather than shattering windows and whatnot, so we can go over domestic flight as well as the international flights. In the middle are basically very ultra efficient, reducing the drag by 50%. Again, we talk about revolutionary innovation, not 1 or 2% drag reduction. I want 50% drag reduction. So some of these blended body wings and different double bubble fuselage design, again, really, really change the needle when we talk about the technology. And then on the bottom, looks like that little guy is not really too little. That's an electric. That's a hybrid electric. Electric flight is coming to you very quickly. That one actually has 7 electric engines on each engine, on each wing. So that's 14 electric engines on that one. So all of that is being worked on again, and really incredibly important technological innovation going on. This is back to space station, again, kind of phase 1, what we're working on. This is just a sampling, some pictures of, again, all the technology investments that we really need to improve, from solar arrays to in-space manufacturing. I've mentioned, as humans and robots working together, fire safety, these kind of things, refueling, inflatables, expendables, we're really working on. So we're taking a look at all those technologies. Show you a little bit of our work here at MIT in terms of the technology development. But I start with my Apollo bloopers.
Jack Schmidt having a few problems.
So we've been to the moon. We didn't have a very mobile spacesuit. And so Jack Schmidt, you might know, was a geologist, a science, but we made his science really hard because he couldn't even bend down to reach his instruments. So on the left, you see NASA's current suit. It's a gas pressurized suit. And then tell you a little bit about some of the designs that we have to literally shrink wrap you. Go through this quickly. Some of our research, again, technology is the current suit. You see on the left, gas pressurized. It's about 140 kilos, not very mobile. When we get to the moon or Mars, a planetary environment, you really need to be mobile and lightweight. And the current systems are injuring the astronauts. We have 26 surgeries, major surgeries from astronauts today. So we kind of came up with a suit within the suit, if you will. And it's 3-dimensional materials and kind of indexes you, because if I'm in a suit, we don't have a small suit, unfortunately, we have a medium suit. So I really need, you have to keep me kind of indexed. If a big guy wears it, maybe he puts into a large suit, you might need a millimeter or 2. So this sizing, because they're not custom fit. So keeping the astronauts healthy and well, but you also still want to keep their mobility. So that's kind of a nearer term technology work. If we want to, and I'll show you just a little bit of the results from that. On the right is kind of an advanced prototype suit down at the Johnson Space Center, and we basically instrument that so we can see inside the suit. We do that with pressure sensing, kind of hot spots. The person moves, you contact the suit, and then you have to move the suit. And so what are those contact forces? How do we keep people safe? You can't read the data, but this is 60 or so kilopascals pressure. Those are all high pressure profiles, mapping the whole body, basically moving in the suit so that we can get influence designs, keep them healthy, see where people are getting injured, and protect them in the future. So this is kind of current, some technology work that's going on. In the future, we hope that we really might realize something that we call the biosuit that we've been working on for a while, 15 or more years, and that would be not using a gas pressurized shell, but putting the pressure directly on the skin of a person. Seemed pretty crazy, seemed like really crazy, maybe creativity, but innovative. And when we proposed it, good thing is I got to write the proposal. We're circumnavigating on our sailboat. It's definitely the most creative proposal I ever wrote. Say, I need to study giraffes You know, they have a G suit built in. I need to study, you know, animals to figure out how can we really realize this technology. And a really important lesson I learned about, you know, innovation in this work over the last 15, going on 20 years is that, you know, don't fall in love with your ideas, because I had to be willing at any step to say, it's not technically feasible. Lucky for us, we've been pushing the needle. You know, again, it is incremental work slowly and say, wow, this actually, we haven't found out technologically why this wouldn't work. We don't have maybe the materials we need and some other things that we've been working on. But we had to be very honest and open and say, it could have been just a great idea, but if we couldn't realize it. But I'll show you how far we're getting in the research. I think today it is potentially possible. And here's just a little bit of the results. Up top, you'll see a circle, a blue circle and a green ellipse. And I'll show you a little kind of animation of that. Imagine if you put circles all over your arm. Because I want to give you maximum mobility. I want you to, you know, really have all the mobility you have here. So if I put circles all over your arm, infinitesimal, and you move, those circles will turn elliptical. So those two red lines, from the circle to the ellipse, they pivot, but they do not extend. From the circle to the ellipse, there's only one pair of them. All the rest of the bisectors change in length. But this one pair from the circle to the ellipse, they don't extend. And then we really do the three-dimensional eigenvector analysis, and voila, you get like a Spider-Man suit. It's really just the beautiful, elegant math that drives this out. We've been working on it, I think, longer than those Spider-Man movies. But that's where the patterning comes from. That's really the basis of the patterning. And that's where you want to put your electronics, because they literally don't extend very much at all. Orthogonal to that is very elastic. Skin is very anisotropic. So we're trying to look at the material. So we really are trying to replicate like a second skin design. Where is it really stretchy and where is it essentially stiff? And then we do, these are strain maps that you see here, mapping all the joints, the elbow, the shoulder, you name it. And again, it's a custom suit. You all get, you know, your own designs. They look similar, but everyone is a little bit different. And so we map then, again, this is strains of about 40–50% in the orange, and then negative strains about 30% in the dark blue that you're seeing there for, again, natural motions. So we have the patterning, and now we need to think about what materials would really allow us to do that. For these kind of custom suits, you're going to put the pressure right on. And some great work from now Professor Holshoe at University of Minnesota was a PhD student and worked on the active materials for his PhD here with me. Shape memory alloys really have a lot of promise. We looked at candidate active materials all over the map, but they have the stress-strain characteristics that are really, you can scale up to the human force level. And so we looked at kind of put on elastic passive materials, put on, say, a tight-fitting suit up to 20 kilopascals, about 20% of an atmosphere. Then could we cinch it up? So I kind of call these the smart zippers, if you will, because our design goal is about 30 kilopascals. It's a third of an atmosphere. That's what the current suits are, a third of an atmosphere. And so we're aiming to have the exact same pressure, about a third of an atmosphere. 20% from elastic passive materials, and then an additional 5 or 10% more from the active materials. And we're making progress, but there's a new center associated with MIT, the American Functional Fabric Association. That's really important, because we really would have to produce some of these fabrics. There's a very complicated three-dimensional shape and different properties of the polymers and the fibers that you want to produce. Okay, a little bit in terms of a helmet design as well. Life support, I haven't mentioned about. If you want to go buy a spacesuit today, it probably costs you about $10 million. And actually, the suit's cheap. It's probably only $1 million of that. Your life support system is about 90% of that, 80, 90. So we also work in terms of what's the life support system. It shouldn't be a 70-kilo life support system that's going to turn me to fall down, you know, when I get back to the moon. We think it should be much more like an explorer, like camping. And so looking at, again, kind of more the systems, the modularity of these designs of the systems. And what about the information architecture? We really want to enable exploration and make these folks smart. So I want to show you what we're doing today with augmented reality every day now, 8 o'clock for the Curiosity rover on Mars. You can don the augmented reality goggles, and here's how we conduct science with all over the world with our colleagues. Is kind of shown in this video. That's a colleague at JPL. We have high-def images of Mars coming back every night. Kind of bring in your team of investigators.
I think we should place an APXS here.
What should we do today? Where should Curiosity go? What images? You bring in the geologists, because we're in a dry lake bed today. That's a Gale crater, and that's a dry lake bed. That's a great place to look for life. And so what images should we take?
You really don't get a feeling for the shape of it when you're just looking at your computer.
How about a mass cam right about
Asking for a mass cam image right
Agreed.
there.
We could really use the higher resolution there. Okay, I think we're ready for the meeting. Let's see what
Put
Jane
that in
and
the
Samir think
timeline.
of this.
Hey, Rob.
Bring in
Hey,
your
guys.
buddies, their
Let's review our
avatars.
APXS target.
And that's the real
Like good
asset that we
targets.
have on Mars that'll
should
take
get
the
some good
pictures and
data
agree
here.
on it. But we're doing science in a very different way, almost in real time, bringing down the high imagery, and then not just having a pre-plan where Curiosity would go a few kilometers this direction, that direction. Now bringing in scientists and the engineers together to say what technology do we have on board and how can we, really leverage, how can we get the highest value of science, on a daily basis. And we have it on the laptop as well, and the website and everything. You still have all that, but I'm telling you, when you put the augmented reality in, you are immersed. It's the only time that I'm on Mars. For those means, then I've jumped onto Mars. And when you see that in the 3 dimensions, it's actually really compelling. And we think that, and we've started to prove it, that we can really enhance the science that we can get done, with our very limited and expensive assets that we have. So we want to go underwater next, and we play around with it as well on Earth, and we've been in volcanoes and looking at things like that. Not everyone, you really don't want to go into a lot of volcanoes with the noxious gases and stuff, but if you can transport people there through high resolution imagery, again, we can get a lot of really good science done. Okay, so that was fun technology, revolutionary technology. Now the really hard stuff, transforming your organization, and the technology all at the same time. I have some lists of some missions that we think we need that. We need the new technology. We need new business models, frankly, too, to really get it done when we're looking at, is there life out there? And when we find life, something we call ocean worlds. And so I'll transforming all of aviation. These are some of the examples. I'll give you a few. I started with exoplanets. How many people know about exoplanets? Oh, not so many. Oh, you guys need to know about exoplanets. There's 6,000 of them. You've been busy working. Okay, what are exoplanets? Well, they're Earth-like planets. We're looking for Earth-like planets. Now, the problem is they're kind of far away, 10, 100 light years away. So we're not going anytime soon with humans. But scientifically, again, we know that there are tests. The terrestrial exoplanet mission just launched last week, great launch. It's an MIT experiment. Kepler is out there finding, and Hubble participates. We kind of put our telescopes together to find these exoplanets. Now, these are artist conceptions of some. The TRAPPIST-1 is the latest finding of the exoplanet system. The reason that we love it is actually 7 planets around a sun, but 3 of them are what we call in the Goldilocks zone. Not too hot, not too cold, could just be perfect for life, for that big habitability question I put up front. So again, 20 years ago, we didn't have a discipline called exoplanet science. Well, today, guess what? The students want to do. They want to find new planets, they want to find Earth-like planets. So, and again, this is kind of my shout out to the artists, because our artists, these are artists at JPL, they're painting the pictures. Again, scientifically, we have the evidence, but that's just like a quick Doppler shift when the planet goes in front of its sun, and we say, aha, we saw a planet there. We've never really seen them. And so painting the pictures, again, the artists, the journalists, people telling the stories so that we can all get behind it. So again, I'll come back to that theme, but always bringing in the artists or the designers with us, the engineers and the scientists. But there's 24 exoplanets that we're really, really concentrated on now, because they're Earth-like planets. And again, they look like they're right in that habitable zone. So very exciting, but very far away. Ocean worlds, a little bit closer to home. Now I come back into the solar system. And Earth being the most important, a spaceship Earth. We're all astronauts on Earth. We're all going around the sun together here. So if you ever wanted to be an astronaut, just think about, well, we already are. We're here, we're astronauts on our spaceship Earth. Tell you more about that. I really like this chart because it's to scale. So of the ocean worlds, we kind of call this ocean worlds in exploration. Earth and Earth's oceans are the biggest. If you look at little Enceladus, really small, really important. It's a moon of Saturn. It's spewing hydrocarbons out. Those geysers, I'm actually from the state of Montana, Yellowstone National Park, and Old Faithful. Well, Enceladus, looks like it might have multiple Old Faithfuls. It's just spewing these plumes of kind of hydrocarbons. Why is that so important? We're looking for life. These are the chemical constituents. It's like the candy store for life. Hydrogen and sulfur and oxygen in these places. That's what we're looking for in the solar system. Europa is up next. Europa is a moon of Jupiter. We know it has kilometers of ice. Looking for life, look for life. Well, what's underneath that ice? First time we looked in Antarctica underneath the ice, we were actually surprised when we saw that those life forms, the little bacteria and things like that. Life wants to exist. Life wants to succeed. So those are heat maps. because there'll be a Europa Clipper mission, which is going to, and then there'll be a lander to follow. We don't know where to land today, so those are kind of heat maps. So if there's heat regions underneath all that ice, and we intend to go there, that's what we're mapping right now, kind of those warmer places. And then you can, Titan, Triton, Ganymede, Callisto, these are great places to go. So we kind of call all that ocean worlds. We'll hopefully have missions to all these places in the search for evidence of current life. Okay, I want to bring my last comments down here to Earth. As I mentioned, it's the only one we have. And so we're lucky to have 20 Earth-observing satellites that just went around in that. Imagine, what do we do with all the data? This is what we call eyes on Earth. So sea temperature, sea currents, soil mapping, soil moisture, tracking storms. Again, this is all of us. This is NASA, we said designs and builds, flies the satellites, NOAA in terms of the US operates them. We have, again, of course, our colleagues around the world with satellite constellations. So again, looking at Earth, kind of the Earth science, eyes on Earth, and these big supercomputer simulations. I want to show you the vital signs of Earth in a few very compelling simulations. This is all the data, the recorded history of temperature from the last 140 years. So we're going to start at 1880. Please raise your hand when you're born. The code is white to blue is 1 to 2 degrees Celsius below a 30-year average mean from 1950 through the 1980s. And yellow and orange is going to be 1 to 2 degrees above Celsius, above that average mean. We're at 1 degree Celsius now. 2 degrees is pretty catastrophic. No one's born quite yet. You guys are young. Thank you for participating. So it's hot. This is 2016, the hottest year ever recorded. 2017 was the hottest year that wasn't an El Nino year. 2016 was an El Nino year. Matter of fact, in the last decade, we've set record after record. We're setting records each month in terms of the monthly records. So, guess what my prediction is for 2018? I'm optimistic. I'm optimistic that we can make progress, but it's really important that, again, we see the data. So let's talk about greenhouse gases. I want to show you carbon dioxide, and I'm going to show it to you in 3 dimensions because we just surpassed for the first time ever 410 parts per million. On this color code, you'd like to be blue. You don't want to be in the yellow and orange. Yellow is over 400. Yellow and orange is over 400 parts per million of CO2 in our atmosphere. The oceans absorb 93% of the carbon, and they're almost saturated. So it's really systems of systems, our ocean systems, our land systems, and our air systems. So take a look at, this is just 1 year of carbon dioxide. This is from 2014 to 2015, a full year of the carbon dioxide cycle. That's November 2014. Take a look at the northern hemisphere. Not so many people in the southern hemisphere. So all that yellow moving into orange then is over 400 parts per million. So kind of spin it around for you so you can see 5, 10, 15, 20 kilometers. So this is the literal definition of trapped greenhouse gases. So if you hadn't seen this before, you might be kind of sad, you might be bummed out. It's really extreme, but I'm optimistic because we can change this. But we have to do it fast. It's urgent that we start taking care of the Earth and the Earth systems, and in doing this, we're all, there's no one that's not underneath that cloud per se, so we really, literally are all in that together. One more about I'm a sailor in the sea ice. I was on the bucket list. I got to go to Antarctica, but the NASA aircraft flies over Western Antarctica to see the glaciers melting and the speed of the glaciers melting. But in the top right, I'm going to show you my next simulation is of Greenland to take a look at the Greenland ice sheet. And it's not just the surface area. We've lost 287. This was for 2016 gigatons. It's 3 times the size of Texas. And Antarctica, down in the bottom, that's the Ross Ice Shelf, lost 125 gigatons of ice that same year. And here's what it looks like. This is what our aircraft flights and our data and sensors on the ground can show us. So again, from Greenland, the Greenland ice sheet and the Antarctic ice sheet are 99% of Earth's fresh water trapped in ice. So we knew we were losing, the glaciers and some of the ice, but the velocity is quite surprising. And so these are the scientific, vector diagrams of not just the ice loss, but the velocity of the ice and where it's coming from. And now we have pooling underwater that's enhancing and greatly accelerating the loss and the calving into the ocean. If the Greenland ice sheet goes, that's 6 meters of sea level rise. Right now we're at centimeters, 20, 30 centimeters. So again, we still have time to hopefully plateau or regenerate some of these things. But we're not headed on a very good trajectory right now, so it's really urgent that we kind of address this. We can see these changes. We take the scientific data every day with our sensors and flying. Okay, so I want to now kind of get ready to conclude. And so pretty simple to me. Now I spend a lot of time thinking about still how to get astronauts to Mars, but I think I have the next couple decades to do that. And I think we only have the next decade to really think about the Earth. So Buckminster Fuller, I think, said it best in terms of having the Earth work, the world work for 100% of humanity. Has to be the shortest possible time, has to be through cooperation without ecological offense or the disadvantage of anyone. So now we're working on that hard. The green line that you see, that's your life support system. That's our atmosphere. That's our precious life support system. And I shrink it down to the size of a football for you. It's only 3 human hairs thick. So that's what separates Spaceship Earth from all those other planets that we haven't found life at yet. So it's pretty precious. Like I say, we're all in this together. We're all in this boat together. And then want to lend my last message that I have. I spent my whole career in STEM. And probably a lot of you have, in science and technology, engineering, math, and trying to say, isn't this, I have the greatest job in the world, being a professor at MIT or going to NASA. But I think we have to talk about it differently today. And so I really do draw the axis between science and art. Bring in the artists, bring in the journalists, bring in the storytellers, help them, it really is a lot about inviting the world, but bringing everyone in. And I put an engineering and design axis there now too, as an engineer, but we have a 3D maker generation. So if they don't see themselves, as a space scientist, maybe aerospace engineer, that's okay. I'm saying, you're a 3D maker. You're the most creative person out there that I see. So you just keep making things. There's place for you to be very inclusive, bring everyone in. I think it's really important. Old school was, hey, you want to be an engineer, it's only the right stuff. You have to be the best in calculus and physics and science. Well, how intimidating is that? So everyone leaves. It's not filtering anyone out. My mind is filtering it all in. Hey, world, you're out there. Well, come on, come do what we do. Come do the hard stuff because that makes you great. But it's filtering everyone in, not weeding anyone out. We don't have the luxury. We need all of these smart, wonderful young people. The next generation, whoever is in school today, is the Mars generation. 2030s, we get people to Mars, it'll be them, not most of us. So that's my last comment, and I'll leave you. I hope you've read the book, maybe Hidden Figures, or seen it. In terms of my message, again, we need everybody at the table. And Katherine Johnson's one of my heroes at 99 years young.
That we're able, and that alone makes us major. We can all sit at the table.
So, what would have happened if Katherine Johnson, wasn't invited to do the orbital calculations? And it's not just Katherine, it's all of her friends. But these are mathematical geniuses that someone had to say yes to. We need you, we need your talent. We're all talented. So that's the end of my comments, and thank you for listening, and I think we can take some questions.
I have a question.
Any questions? Questions, yeah, sure.
So, Deva, at this symposium, we're discussing the ways that strategy flow into, connect to, or just don't connect to implementation. And NASA's a special place in many ways, but one of its special qualities is it's a highly distributed organization. And historically, there have been waves of centers collaborating and competing. Can you comment on the role of your innovation initiative in, if the mission is the 3 questions you ask and the strategy is now Moon to Mars, that's the strategy, what is the role of these innovation, the campaign, I'll call it?
Right, campaign and kind of have, it's a great question.
In
Again, when you have distributed, so a couple examples. I'll point to communications first to make that kind of one NASA. So you go to any conference or so, you used to see Johnson Space Center, they're doing great stuff in human spaceflight, Langley, but we had all the centers, almost 9 centers kind of competing against it. So we said, no, communications is one NASA, and you're all invited, but we all have the same message, because what the outside people think, so there was some room there for we're all under one tent. There was some that one size doesn't fit all in terms of innovation as well. Realizing the expertise, let's say, so what we did across the agency, actually there's capabilities mapping, and so say, material science, well, it's great at Langley, it's great at Ames and things like that, but every center surely can't have all the expertise. You just get way too thin. So we said capabilities lead for that, material science. It ended up being, okay, at Langley, but guess what? For our missions, our Mars missions and things, you're going to work with the other centers. And then once we can get that done at NASA, then we can say, okay, we have our act together. So now we can talk to the world and look for their expertise as well. But it's a great question, because some of these things we really kind of consolidated or make one message. Other ones we said, one size doesn't fit all. On my kind of brainstorming chart, I had an example of SwampWorks from Kennedy Space Center. Kennedy Space Center is an operational center. So their focus is the big operations. But guess what? They want to do creative things and do smaller things and get their hands dirty as well. So it works out for Kennedy to have SwampWorks. It's really, it's like, Skunkworks or PhantomWorks or things like that, a place that people go there and do their work. That doesn't work, say, for the research centers. You can't have one place across Langley or Ames or Glenn. You want everyone to be doing that. So we really had to listen, get those benchmarking, and then again, kind of say what's the right way to do this when it's distributed versus kind of consolidation. And we definitely found lots of examples that would go into both. And but then again, also looking for consensus, because when you say that you're going to look for capabilities, you're necessarily going to shut some things down as well. So in situ research, not all 9 centers can be expert in these things. So the hard decisions are too. It's like you're going to give it to one center or another one, tell everyone to work together. You can do that by putting the resources that you only get the resources if you are working together. But still, you can't have all the expertise, so you necessarily have to shut it down or transition people in the organization, which we had to do to kind of have some of the capabilities and some of the parts that were then distributed across the agency. So that's a few examples.
We've often told about space that the advantage of this more about its collateral innovations.
What about collaborative innovation?
Collateral advantages that you would get on a mission to space or whatever. Right?
Yeah, I think if I hear and understand the question, is about what about collaborative innovation?
What are the collateral innovations that one gets out of space?
That we get. First, you can get it across your multiple centers for sure, teaming up. So when we had the Innovation Day across NASA, it's exactly what we did. We said we have some resources and we want to fund some of these great ideas, and we wanted to get dozens, and we actually got hundreds of ideas in, so we'll try to fund the top 10, but then the rules of engagement were, guess what, you have to work across 3 centers. In that sense, we wanted people to work across different disciplines and different centers. And guess who, one of my favorite kind of innovation prizes and teams was from the lawyers. I usually don't give lawyers too much credit, but I'm glad to say, because what they came up with, their innovative idea was actually, kind of an IT system and information sharing. And they needed it, and they saw the need. And, but again, if they can do that, our CIO, our Chief Information Officer, was thrilled, and things like that. So again, having people, and it was, again, everyone across NASA working together. But again, that's just one example too. Again, the lawyers, they had scientists and computer IT people on that, but we made them work kind of across from different agencies to collaborate for essentially some incentives.
Back in the day, when it was the moonshot,
Mm-hmm.
The perception anyway was that, whether it's true or not, the perception was that came from the White House saying, make it happen, make it so. Has it been the same way round for Mars, or has it come? Has the initiative come from you, or has the initiative
So
come
good
from
question. If you didn't hear, it was kind of the moonshot. The perception was that came from the White House. There was strong leadership for sure. Truth in advertising is actually that that initially was going to be Mars. And so thank goodness, I'll give credit to Bob Siemens, an MIT colleague, and the deputy in this case, because Administrator Webb was not a technical person, but a very astute political person. And Bob Siemens was one of President Kennedy's college roommates, colleagues at Harvard. And so when the president or executive said Mars, he said, we really don't know how to do that. I mean, that's too much of a moonshot. The moon would be better, President. So again, working together, it was still really tough. No one thought it could happen. So, it'll go down, I think, historically, is great leadership. Marshaling the resources. It's not insignificant that was about 5% of the GDP. Right now, NASA's entire budget is 0.46, less than 0.1%. So this is an important, part of that too. Not just to throw money at it, but that was when we were going to do it. Everything was focused on that. We're in a different, the space race, the space age. I think we're in a very different point in history today. But I would expand on that in terms of more now the global cooperation, kind of with all nations. I would submit that one of the best things going between the U.S. and Russia today is our human spaceflight program. We're working together like that. I've been working with Russian colleagues since the 1990s. We work together like that. So that's soft diplomacy. It's the science, the technology, they're working together. We're completely dependent on one another, the international partners. And so I think right now it's much more about global soft diplomacy and having folks to work together and again, everyone kind of come in to participate.
Well, let me ask us to thank Deva.
Sure.
We've kept you.
Oh, I've kept you guys late. That's okay. 4 or 5 minutes.
Great.
No, that's great.
And, so please join me in thanking Professor Newman.
All right, so we're going to get going here with our last session with speakers. We've had a full day. We have 3 more case studies, and just reflecting on today, we've heard some case studies. The last group presented some cases. We've heard from people talking about frameworks and how to approach research and theory. We've heard some observations about current practice, and it seems to me there's an opportunity to get lost in the gaps. So as we hear these case studies that are about to be presented, I guess I would probably ask you to go back to some of the advice we got this morning with Hal's keynote. And think about, are you missing something? If you feel like you're missing something, if something doesn't make sense for you, then maybe you ask, what is the connection that I'm not making? Where might I be wrong? And the topic that we're here to talk about this conference is really about how do we bring together different perspectives to close this gap. And if we can't do that here, then it's going to be difficult for us to influence other people and help them to close that gap. So yeah, I think by the end of this conference, we want to be able to say, okay, here is a way of thinking about across all of these different perspectives, ways of bridging the gap, mental models, and so forth. So with that said, let's hear 3 more case studies. We will have first Caroline McDevitt from Silver Thread to come talk to us, and then we'll hear from Gillis Sion from University of Tokyo, and finally from Torben Andersen from Copenhagen. And we will have a panel discussion after each of them, after all of them have concluded. So save up your questions for after all 3 of them have concluded, and then we'll have a quick discussion about these cases. Caroline.
Press the green button to advance the slides. Okay, great. I'm getting a thumbs up from there. Hi, everybody. I should point out, first of all, I'd like to acknowledge my co-authors of this work, Ulrika de Fort-Menares and Alain Fiocco. I'm currently at Silver Thread. Ulrika is currently at Indeni, and Alain is currently at OVH. But this case study is not about either of those companies. It's about a company that we previously worked with. And so I'm going to give you a bit of a case study about changing, or how do we implement, given a strategic priority. So you have to go back in your mental model. You'll see some things in here that make you laugh given the state of the technology from 2007. But back in 2007, this company that we're discussing, they had decided that the strategic vision was that people around the globe would be using the internet to share and consume video. And that it would be, the internet itself would be expected to provide online training, TV shows and movies, and live and interactive video meetings. And I think we can all pretty much agree that that strategic vision actually came true, because that's one of the things we use the internet for today. But we didn't in 2007. The company was a large networking company, and so they basically just said, okay, video over the internet, that is our strategic vision. They then, in that corporate culture at the time, said, okay, you SVP, that's yours, you go make it happen. And so the SVP of the operating group got on the responsibility, and he did what one normally does when one is given an objective, is he said, okay, I need to get a bunch of subject matter experts and get them to figure out what the heck this means. And so that's exactly what he did. And so just to give you a little bit of a, why is this hard? Or more importantly, why was that hard in 2007? If you think about it from the point of view of you and I are having a video conference, I'm here, you're in Tokyo, and we want that to be as smooth as possible. And so the video, I'm initiating a video call, it has to transfer over the intranet and then the internet to be able to have a good video call with you. And so what we really want is the endpoint to actually say, hey, I'm actually doing video that's different, it's important. If there's any problems or losses, it needs to be able to report that information and say, hey, I'm receiving, and the video quality was crap, and then it needs to send some information to somebody that can do something about that. And so why is video hard? Yeah, I'm sure everyone remembers at least when we were doing, when you used to click on a link, the page would load and various things appear at various times, right? And that's still how the internet works. Video can't do that. I can't have this sentence have words 1, 5, 8, 3, 2 arrive. It doesn't make any sense. And so that's one of the big challenges for video. Video consumes way more bandwidth. And there are lots of different types of video, and they are all very different. The other important thing that we discovered was, success is beyond just delivery of the end-to-end systems, but the customers, we as a company that makes products can do wonderful products, and if the customers don't buy them and deploy them, then that was a waste of resources. And so basically the subject matter expert says, we need new capabilities and we need to enhance existing capabilities. How this would have worked in the old way is, as you saw from the picture, there's lots of different elements in that system. Each of those would have been a different business unit, or is a different business unit. They had responsibility for their own products. They're driven by their customers and their consumers of their products. They're driven by the bottom line for that business unit. And they have their own development processes within each different business unit. Why that's important is, here's just an anecdotal example, and I will say it's not actually a fully true statement, but it was something that we really noticed. So if I wanted to develop a video conferencing system like this, one of the little elements in there is a phone. And how the video conferencing system works is it needs some special features on that phone. Well, those are two different business units. The people who are making these big, huge room-based systems, if they sell 100, 200, 300 in a year, they're good. Like, that's amazing success for them. They're high price point elements. The phone sells hundreds of thousands of them. And so there's no motivation for them to say, oh, I'm going to stop my product development process and insert your features because I'm going to sell 300 more phones. And so that was sort of one of the problem spaces that we were looking at, is like, how do you get all these people to do these features that isn't particularly motivated by their bottom line. So what happened is a new VP came in and he made a sort of a profound statement and said that these architects, these people who are looking at the problem, they're not only going to study the problem, but they're going to help the company move forward with the solution. What that really actually meant is, and I'm using a picture for people who are from the SDM program will recognize as an Ed Crawley or a system architecture approach to system development, is there's a technical side and then there's a business side. In most organizations, that's the case when you're doing new product development. You have somebody who knows what the business and the customers want, somebody who knows what the technology wants, and they get together. What we discovered is actually there's a piece missing there. When you're trying to do something really new and different for the organization, what you need is an intersection between the technical and the business and somebody who's going to architect and design a new process and set in place the management stuff. So that was sort of a new approach that we put in place. So the objective of taking this strategic vision of what can we do with video and turning it into how do we capture hundreds of $millions in addressable market with development efforts that go across multiple products and teams in multiple countries, we would need buy-in and commitment from the different relevant product BUs. System-level customer requirements would need to be translated into system use cases, and system architectures would need a direct way into product development processes. So the first part, the buy-in challenge, how do you get everybody to buy in? The problem is business units don't work that way. They're all independent, and in any given time, there is product development that is already executing. They're already moving forward with it. They're planning the next release, and there's other stuff out there that they're not even thinking about yet. When we're starting to put together some of these systems, we ran into this situation where, okay, I need for this system to function, I need BU A to have something that's in their release that they're not even planning yet. I need BU B to have something that's like even two beyond what they're planning. And I need BU C to disrupt what they're already doing and put some stuff in things that they're already executing on. And so what we came up with was, and again, this is the key to why we thought we needed a new body there, a new process person is a new process. A business commit, but at the higher level. And that one of the key elements here was concept of an architecture commit. So getting all of those people in the room to understand and be presented with the use cases, which I'll get to, and a description of the technical architecture, and so what's going to be needed to make this come alive, and then where a vision as to where their product fit within that, and commit to make room when the time came in their product space. And so that was quite challenging, but we thought it's really important. And we got together a lot of senior VPs, and they had these really interesting conversations. Like, how can I commit something for a year from now? Like, if you don't, all these people who are spending resources to get us to where we want to be are going to be wasted because a missing piece of the system is not going to be there. The other important thing, and this actually turned out to be hugely important, was system-level use cases. So what they described is, what problem are we solving for the customer? How are we solving that problem? What roles do the individual products play in that solution? What are the gaps? Sometimes we would put together this vision of an area, and there's stuff that the company didn't make. We need to partner, we need to acquire, we need to come up with a way to put that whole system together. And then how do you put it together and verify it as a system? What was quite interesting is we presented these as compelling visual stories, not just a standard agile, as a customer I want to be able to do the following, but showed how the customer would be able to use this new capability. So they brought that vision down to an actionable level and tied it to the customers and value. So this is an example of a visual for a use case where, that it actually says, the endpoint is going to announce, and then there's going to be an acknowledgement, and then there's going to be an indication of bad video quality. We had a little fun with it, and
George, take a look at that hurricane's latest track. It's not looking good.
It's made a reverse loop. It's headed right towards us.
The latest advisory gives us less than 24 hours before it hits. We need to activate the emergency operating center team.
We'd better get corporate involved, too. I'll send out the emergency notification.
Thanks. I'll put together a briefing.
I'm not going to show you the whole thing. It's on YouTube. The first one was me. As I said, we had a lot of fun, but that was important. We were trying to figure out how can we get people to understand what these use cases really mean from the customer. How are they really going to use it? And this was one, but we created a number of actual videos, production quality in some cases, that described and showed how the customers are really going to use that. That was really a key way to be able to say, this is what the strategic vision is, this is what it's going to be and how it's going to be implemented. It's on YouTube because the sales team, we did it for an internal thing and the sales team wanted to share it with their customers, so it's there. The third sort of key area, which shouldn't be very complicated, but it was a challenge for us, is we needed a path for the system architects to the product development. So given those use cases, we had to break down the architecture and then figure out what the individual components were and use sort of standard requirements traceability. What was hard was business units were not used to having input. They were supposed to be the initiators of the features. And so we just had to come up with a process to work our way around that. So, what actually happened? Well, we delivered 2 different system architectures and 3 system releases. We were able to capitalize on the delivery of the corporate strategic vision. There were 600 individual resources participating, representing about $15 billion in revenue. The team was awarded an internal award with Best Core Technology. And more importantly, the company actually adopted some of the products right away because it was game-changing for them. So sort of taking a step back from the case, what I see as an important gap between the strategy and the execution, particularly in this case, was a lack of a process. You're trying to do something that isn't, when you have a strategic vision, you're trying to do something that isn't part of your normal corporate culture, and you don't, by definition, have a way to do that. And so we ended up having to cross that chasm by evaluating and creating a process to be able to do that. And then, as I mentioned, the impact of the system use cases were profound because it was a way to show that the vision could be implemented and how it would work for their customers. So basically, just sort of in conclusion, implementing the strategic product development is not business as usual, and it requires a new process, and that the compelling use cases can ease the transition from the strategy to the execution by showing how the vision can be moved into something that is useful and tangible. And that's it. Thanks.
So good afternoon. I'm going to be presenting a work that we've been working on for some time now in Kashiwanoha, which is also where University of Tokyo has a different campus. Particularly, we're working on an SVN model-based approach to assessing the gap between strategy and implementation in the case study of Kashiwanoha Smart City. I'm presenting in name of several people, as you can see here. So I'll give you a short introduction, explain you about the research design, give you some of the results, discussion, and conclusion. So particularly the case of Kashiwanoha is a new town. It's been developed by one real estate developer. with a particular focus of focusing on smart energy grid. There has been a significant technological advancement in the area, but there's a need to address several of the social issues that are related to that. The Kashiwanoha Smart City is located about 35 minutes outside of the center of Tokyo. It's in Chiba Prefecture, so it's just outside of Tokyo, and it has around 11,000 people. Its aim is to be an environmental symbiotic system. So the idea is that several social elements, but environmental elements and technology works together. At the same time, there's a very strong stakeholder collaboration, which takes place in the form of UDCK. UDCK stands for Urban Design Center Kashiwanoha. So UDCK is quite an innovative stakeholder collaboration. It was initiated by the University of Tokyo. And the idea is that this platform helps advance the collaboration amongst those different stakeholders. Particularly, they try to implement research in collaboration with the different stakeholders. They try to connect the technology more tailored with society and work as a collaborative space for urban development. And they try to organize activities for people in the area. However, there are several problems that we can see now that the development has been occurring for about 10 years or so. So in general, Japan has a shrinking and aging society, but there's also within the area a lack of cultural identity, and that's something we see with many different new towns. So there's some commonalities that we can see. One is that they're newly emerging. They're highly complex because they're connected within several different elements. And at the same time, there's many different stakeholders involved. So an in-depth understanding of the stakeholder relationships is required. And it's challenging to implement a smart city strategy. However, not everything is a problem. What we see is that, especially on the technology side, most of these elements are advancing very well, and they're being implemented relatively well as a technology itself. But the issue is more acquiring the necessary data from the social side. So tailoring this technology based on the needs of the people in the area and the context. So as for research design, the aim of the students basically was to frame the newly emerging socio-technical problems in the smart city and to understand the areas of strategy implementation that require improvement. To do so, they created a stakeholder value network to understand the emergence of the problems and the gap in between the strategy and the implementation. And they developed some suggestions for the improvement of these elements. So as I explained, the research is developed by some students, about 25 students in total. It was intended as a field-oriented exercise for the students to develop more fieldwork competencies. It's conducted in the Graduate Program in Sustainability Science Global Leadership Initiative, which is in the Graduate Program of Frontier Sciences. The group in general was focused on finding tailored solutions for the newly emerging issues. Now, of course, I'm speaking in very broad sense, but some of the problems that they are addressing is, for example, bicycle sharing and car sharing technology. So in terms of the car sharing, it's electrical cars, and the bicycles are typical shared bicycles that you see in many urban areas nowadays. But the problem is that due to the collaboration, often these are part of some experiment by the university, they're being funded by the local government, which means that often after the end of the experiment, the there's no budget left over. And what we notice is that basically people aren't using them enough. So they end up disappearing. So there were 5 different teams. They each focused on different elements to find different issues and different solutions. For one group focused on the energy supply system, which is currently unresilient, and as I explained earlier also is that there's basically a need to increase the diversity of energy supply. There's a lack of cultural identity related to the development of the smart city, the new town. Basically one of the goals is to attract world-class startup companies within the area, but basically the developers are struggling with that. There's a lack of quality of life for international residents. So there's still a big cultural gap in between the livelihoods based on the needs of the specific target groups. And in general, the population is in decline. So different groups use different methods to address the needs of the area. So they all started off with literature review, and then did different types of secondary data documentation to grasp the background of the area. In general, and comprehensively speaking, with the different groups, there were 4 questionnaires conducted, there were 8 stakeholder interviews, and a focus group discussion to discover the relationships and viewpoints. So this was helpful to develop the SVN. So you can see here the different target groups that they had and which methods resulted in that. So there were over 160 total responses for this. So the SVN is being used to evaluate the impacts of the stakeholder relationships on the success of the Smart City project. It reveals the value flows. It helps to understand the underlying causes of the socio-technical problems, and is used to translate the strategy into implementation. So there's a slight modification is that in this SVN, we're trying to reach a comprehensive understanding of the different value flows. So for the results. So here we can see especially the location of UDCK, which is basically a very strong collaboration between the government, academia, and developers, as mentioned. And we see that there's many different values going to the other stakeholders. Just to briefly explain how to read this map is that in the central area here, you have the different types of services, and they are connected with the different stakeholders. The reason why they're shown like this is because it's very comprehensive, so they're including all the different elements that they managed to identify as problems. So the government includes local government and prefectural and national. Academia is basically local universities, so there's 2 local universities in the area. And the developers are mostly Mitsui Furusan. The residents are particularly the residents that live in the area and direct surrounding area. The businesses are all local companies, and then we also have incubators. So incubators are basically organizations set up to help startups to develop innovation. What they found was that UDCK is lacking visibility. So there's a need to promote and make it more accessible. And there's limited stakeholder empowerment. So there's basically an underutilization of the potential of UDCK and related to the solving of the socio-technical problems. So how can we integrate these needs? So there's a lot of literature talking about a transdisciplinary approach, which can really help to co-design the projects with the different stakeholders and bridge the problems by integrating society's needs. So this is an example of the policy flows. So similar chart as earlier, but we got rid of all the non-relevant elements for this particular point. But what we see is that there's many policy flows going to the different areas, but they're all coming from government. So basically what we see here, there's no co-creation. Again, UDCK does function well in itself, but it's not tailoring based on the needs of the residents and businesses and incubators. So currently, especially the residents are less involved in the strategy implementation to solve the issues of utilizing the technology in the area. But by empowering the residents, by providing space for them in the platform of UDCK, some of these services could be solved. So basically, the smart city strategy was to attract enterprises, and the implementation in this case was to understand what enterprises are in demand. As for some discussion points. So previous studies have already addressed or suggested transdisciplinary approaches to solve problems found in traditional governance, so especially when you're talking about top-down approaches. So collaborative governance is required to tackle some of these problems. But it is especially difficult to obtain data for this. It's very time-consuming. Often the sample sizes are limited, so even though if you make certain suggestions, they're often not always tailored based on everybody's needs. And in a lot of areas, when you're dealing with people, there's also questionnaire fatigue. So basically, people don't want to answer the questionnaires anymore. By sharing ideas and working together, however, there could be, for example, the development of a database of the questionnaires that have been conducted in the past, so the smart city can meet the needs of the stakeholders. So adding feedback flows from residents, businesses, and incubators to the government enables for a good information flow between the stakeholders, ensures suitability of the strategy to address stakeholders' needs and reduce the likelihood of emergence of problems. And one of the examples that one of the student groups provided was to literally connect the different stakeholders more through different pathways to form a stable social structure, to make the smart city more inclusive, and to help establish stronger cultural identity. So Kashiwa Noha Smart City has developed a strategy and implementation to achieve the goals. And basically, we identified that UDCK in particular has already the platform to bridge the gap, but in reality, it needs to invite the different stakeholders more. So, however, newly emerging socio-technical problems indicate that to this point, the implementation is still lacking. And the solution, as suggested, is to apply more of a transdisciplinary approach. So thank you very much for your attention.
Well, good afternoon. I guess I'm the last presenter this afternoon. Great pleasure for me. Thanks for staying put. What I'd like to propose is, well, going back to the theme this morning, the gap between strategy and implementation. I would suggest it is at least partially a function of the way we perceive the strategy making process. And how we practice it. And I would like to suggest an alternative view that I think is consistent with the empirical evidence and that might serve as a basis for ongoing research in this area. When we look at strategy, we try to strategize, this is where we are. We are operating an existing business model in a given context that we think we know. We try to analyze it, thinking into the future, and we intend or develop an intended outcome that exemplify a future business model with a new understanding that is emerging along the way. And that actually represents the gap. Right, so here we are, we're looking into the future. There is, or rather we can reason about the future and think about how we get there. That constitutes the gap. We, in practice, cover that gap by something we call implementation. We do things to get there, and the transformation is supposed to happen along the way. That's the gap. The way we think of strategy, we had presentations about how we teach strategy. This is how we teach strategy. We try to conceive of the current context and the ongoing changes. We do rational analysis to ensure that we understand the current trends, etc., in order to be relatively sure that where we're going is the right perception of the future. And herein is, of course, the challenge. When we teach our students, including executive MBAs, whether it's Copenhagen Business School or MIT, I suppose, this is the model that we teach. And there's nothing wrong with the model. It is the foundation of strategy. The argument was, we're living in a turbulent world, we need to have rational analysis to guide us. And that all makes sense. The problem, of course, is that the world is changing. There's a lot of uncertainty, and that is the challenge of the implementation process. When you look at the evidence, organizations that do follow a rational analytical approach actually do outperform. So there's nothing wrong with the model. I think the way we teach it, we also challenge the students to look at facts. Don't let you guide by what you read in the newspaper or what you read in the latest management book. All of that is good. So there's a lot of good things to be said about this process, but it's not enough. So there is a gap. The problem or the insufficiency, maybe I should say, about the conventional model is that the long-term strategic intent, because we're thinking maybe 12 months, 3 years, 5 years ahead of time, is that it implies assumptions and beliefs about the future that we cannot be sure will happen. This is my maybe wanting illustration of a changing world that doesn't follow a linear process. In other words, in a turbulent, nonlinear world, we require frequent updating about the changing context. That's the challenge. And I think it's part of the solution, and I think many of the inputs we've seen along the day actually contest to that. But very few organizations can do it. Another aspect of this, or consequence of this, I guess, is that it becomes more important to adapt rather than achieve specific goals, because the goals might change. I know this is simple, two-dimensional depiction of a changing world, but it's irreversible. What has happened in the past doesn't come back. So if you're not able to adapt, you will be lost one way or the other. Just keep that in mind. One way to look at this, and that represents the alternative view, is that the people that do things in the organization, and we had many examples, are the different teams out there that operate in the field, frontline employees that actually do the things, the managers that are involved in these processes, etc., they're spot on. Oh, here it is, right? They're right on the green line. They observe what is happening there. Now, if we can gather this information and bring it back to the leadership team around top management, they can use this information to update the strategic intent and thereby adapt the strategic intent. It might not hit completely the green line, but it's not static for sure. So the idea is to have this ongoing updating in the process. And if you can do that, there's a reasonably, or certainly relatively higher chance that you will adapt to the current market conditions. Thought experiment. Here we have the market movements. That's what I'm supposed to illustrate with this green line. Sorry again for the simplicity, so I can follow myself. Here's company one. How are they going to perform in terms of adapting to the context? Probably not so well, because again, it's an irreversible process that we're trying to adapt to. So there's a gap. 2, supposedly slightly better. 3, I suppose, even better, because they know what the customers want. They provide the services they need. They know what the total demand is. They can manage the inventories, et cetera, apply the proper technologies, and so forth. Now we can formalize this. Sorry about the math. I know it should be refined a little bit, but the logic is simple. For a given resource and technology endowment, we as economists claim that there is an optimal way of utilizing this. So if we can agree that that is a fair assumption, those that are closer to fulfilling the different factors that matter in the given market in which the company operates will be much closer to that optimal level. That's what this is supposed to show. In other words, the CD difference is the difference between what the market wants in a certain type of strategic factor and what the company actually performs, what delivers at a given point in time. So the higher the discrepancy between these across the different important strategic parameters, the lower the performance, relatively speaking. So it's a very simple way of setting up a model. And I'm not really going to talk a lot about a mathematical model, but it allows you to do interesting simulations. And if you do that, it actually shows you that those that are able to adapt actually outperform both in terms of higher performance and also lower risk or variance in the performance. And incidentally, it gets very close to describing what we actually observe empirically across industries. So you have a very small positive tail of companies that outperform. This concept of sustainable competitive advantage is very rare. On the other hand, we have a very fat, long negative tail of companies that have a hard time. And that is another way of looking at the gap. Understanding what is it that those that are in the thin positive tail, what is it that they can do? And what can we learn from some of the difficulties the companies have in the fat negative tail? In terms of, we can extend this model, so rather than, or rather we can compare a situation where you have a long-cycled diagnostic control system in the conventional planning model compared to the faster updating, and that will show you a much more, or a more distinct advantage of the fast updating. Not surprising. So we can actually use this as ways of identifying interesting exemplars that we can study. but we already have a model that explains or can give us some of the key factors that makes a difference. Part of this is inspired by cognitive science. So if you look at how the human brain works, we get a lot of fast impressions from the environmental context. The body observes, our senses observe things that happen around us. And we use this to put the information through various loops deep inside the brain, I've been told, into the frontal lobes where we have this distinct human capacity that allow us to generate forward-looking reasoning. That is really what we do in rational science. That is what the planning really does. Now, or among humans, if these many impressions fail, if you don't get updated insights from the environment, you get mental diseases, types of schizophrenia and so forth. And I'm not the expert, but I've been told. Fortunately, in humans, it's rare. Now, I claim that we can use this metaphor in organizational context. I'm just trying here to quickly illustrate how we might perceive of that. Now, the description of the short positive tail and the long fat tail illustrates that maybe among human beings, among organizations, it's the other way around. It's only the very few that are able to get this updating, whereas most have a hard time. And we can hopefully find different ways of explaining that. Do we have examples of this? We have the military here represented, West Point. Good examples from, I guess, special forces particularly, where you have a quick updating out in the field and good coordinators in the back that increase efficiencies. General McChrystal wrote a whole book about how this system actually was implemented in a very different context and difficult circumstances. So there are examples of how this can actually be done. In terms of my own empirical studies, they confirm some of these findings. So if we look at it's a 2x2, so even I can follow again. If you look at a given population in the industry of firms, you can see the extent to which they actually have this or master this, practice this central reasoning capability. We can call it strategic planning, if you will. Low, high. And the ability to take decentralized initiatives where people in the field where they operate can actually take actions and learn from those actions. And the interesting thing is, those that can do both outperform the rest. And they show exactly those characteristics of higher average returns and lower variability in returns. So high performance, low risk. That's pretty neat. So I think there's a strong empirical evidence to suggest this model. I'll jump over this. Looking at Brightline, I just looked at the 10 principles, bearing a few misprints and misspellings and so forth. I think I can find the 10 principles in my model. So I just suggest here is possibly an interesting framework to generate complementary insights to these processes and identifying the gap in a different way than we have seen before. And obviously, and I didn't talk in detail about this, but this has to do with how the organization is structured, how the decision structure is set up, how communication is enhanced between different decision makers in the organization. The cultural aspects of the organization to support open communication, collaborative learning, and all these things, which incidentally is something or relates to strategic leadership. And then we're back to the theme this morning. I would suggest it is more than just the CEO asking questions. That's a good beginning, but it's also thinking about how do you organize and set up the organization, create a conducive organizational culture, and obviously also, as we've seen in some examples here, using the proper technology to enhance the communication capabilities in the organization. I guess that's it.
Yeah, all right. Good. I'd like to invite Brian to tell me what I'm going to do next.
So, just because of other logistics, what I'd like to do is, if you have a question for the previous three, let's go ahead and ask it. But let me ask the next panel folks to come down and assemble. So we can, Tom and Carol Ann, where are you? Very good. So any question for the previous three?
I've got a comment for Torben, if that's allowed. Is that allowed or not?
Quick comment. You can make it a form of a question.
I'm not sure how to put it in the question, but the sort of model you were talking about, Torben, is what is actually very similar to what Richard was talking about. And there's a really good, well-engineered, very rigorous model, Bible system model that does that. You mentioned about outperforming and lower variability. It also gives long-term longevity. So a guy I know, a Swiss guy I know, did research on confirmation to that normative model and the likelihood of organizational crisis. And it's a minus 0.78 correlation. So it's a 78% reliable predictor of whether you are or are not going to get into an existential crisis, like whether you're likely to fail or not. So I think it goes beyond just the outperformance thing. It's survival worthy as well.
Well, thank you.
All right, good. So let
I
me
like
just,
the model too.
Just let me make an editorial comment. So I think this panel that we just had was a great example because it spanned what I perceived the range from implementation projects to a discussion of strategy. And one of the threads that I saw going through that is a question about the governance function in the organization. How do you connect the strategic or centralized thinking with the decentralized action? So as you reflect on the presentations that you just heard and also on the content of the day, think about that over dinner tonight or whatever. What is the role of the organizing function, the coordinating function, the governance function in connecting these different activities in the organization? The implementation projects, the product development projects, the individual initiatives, the learning that comes from analysis of the way the system is functioning, and then also the planning and saying, okay, what are we going to do in the coming year? Where do we want to be in 5 years? Because I think that's really getting at the issue of closing the strategy to implementation gap. So I think congratulations to the panel for exposing that, and I look forward to hearing the discussion here.
Great, thanks, Eric. You've already been congratulated. That's great. So we're the last thing between you and our reception, right outside. So I should tell the SDM students to text your classmates who may be already outside and tell them to wait for us. All right, so there's some food and drink left. But, this last conversation, which began, I love the diagram, Professor Anderson, of the human cognitive system. reminded me to remind you that tomorrow afternoon there are 3 workshops. And these 3 hands-on workshops are part of a parallel effort to instrument teamwork, to open up our research to more sensors across teams of teams working on complex problems. And so there will be, the great bulk of these workshops will be hands-on. So please take a look, and tomorrow it'll be first come, first serve. I think there are seats for 20-some per workshop, so there'll be plenty of room. But please think about it. So I'd like to kick off this last panel for today with more practitioner reflection on what I would call drivers of this gap between the strategy and implementation functions of organizations. And I've asked them to think about concrete examples from their experience. So if we could start, and if you could, Tom, introduce yourself.
Certainly. Tom Maher, I'm a Senior Director of Electronic Systems Integration at Case New Holland. We make earth-moving equipment and agricultural equipment, so right outside the window there, they're digging a bunch of big holes with yellow equipment. It's got the wrong brand name on it, but that's the kind of stuff I develop. So the thing to me, it came through on some of these presentations today, but what's in that, I think we really do need to look at what's in that gap and what's forcing it apart. And a lot of it in real life, I'm an implementer, by the way. I'm not a strategist. I'm downstream. I'm an implementer. A lot of it is human factors, emotional factors, guesswork, bad assumptions, unspoken dependencies, yes men, overbearing strategists, to put it nicely, overly aggressive managers. There's a lot of things that the implementation team simply does not want to deal with, because what the implementation team does is they define everything in one of 2 ways. It's either something that helps me get my job done, or it's a boundary condition. And anything, including managers, including the strategy itself, can be a boundary condition. And what do you do with boundary conditions? You work around them. And you can tell a good implementer anything you want, but once he or she understands the mission they're on and has internalized the mission they're on, that is what you are going to get, is whatever they have internalized. If you can't make them internalize it, you're not going to get it. If you can make them internalize part of it, you'll get part of it. If you can make them internalize all of it, you'll get all of it. But whatever you leave out of that equation, they're going to turn it into a boundary condition, including your downstream directions after they've already decided what it is that they're going to do and what it is that they're capable of doing. If you come along later and try to correct, adjust, discipline, enforce, whatever, do whatever you want, man. They're just going to work around it, and you. So I think those human factors are really the key to this solving this problem. And you can have whatever strategy you want, you can have whatever brilliant ideas you want, but if you cannot get that team to internalize what it is that they're supposed to do, and then somehow show that you have accountability in that downstream result as well. I heard a lot today of kind of like this handoff mentality of, okay, implementation team, just go do it. If you can't put your accountability on the implementation side of the line, you're already talking about diminishing returns. So my input would be that we've got to look at those human factors and the relationship factors that really enable or disenable the implementation team from owning the end result, and the strategists from owning the end result together. That's where I see is one of the major factors driving the gap wider.
Good afternoon, everyone. My name is Karina Ellis. I am an engineer/MBA by training. I spent the beginning of my career at the Gillette Company in their manufacturing plants. I moved on to being a new product development program manager for medical devices with stints both domestically and internationally. And currently, I work as a business project manager for MIT Lincoln Laboratory. For those of you that aren't familiar with the laboratory, it's a federally funded research and development center. What we do is we take novel concept ideas that the government wants to test out, we build them, test them, and deploy them, and after successful demonstration, we'll help transfer that technology to industry so industry can mass produce them. So basically, we work as a prototype house for the government. It's a really unique position to be in. And we try to really minimize that gap as much as we possibly can. From a program management side, we do really basic things. We keep schedule reserve and cost reserve to really protect us against those unknown unknowns that we've been discussing all day. On a more quantitative side, we do earned value light. We do some Monte Carlo analysis on scheduling as well. But I think, as Tom mentioned, one of the most important things is our people. We have to hire cross-functional individuals who are not afraid to tackle these new and emerging technologies. Not only that, but we have to feel that throughout the organization, particularly from the top down. The senior executive managers have to be pushing that agenda and really understanding that we have to be agile in order to take risks and really accomplish new and novel things. We need to feel that in our process systems, in our streamlined documentation, and we need to feel it in our facilities. At Lincoln Lab, we have a very large high bay, and one day it will be a vibration testing facility, the next day it will be a clean room facility, and then it will be a shaker table. To maintain that flexibility and to have your management allowing that is very, very important. Our polymer lab folks, they don't just mix epoxy every day. No one in our organization does the exact same thing every single day. Someone on the program team will come to them with a new application technology that will really help a program. They read about it in a journal article. We'll try it out. It's worth every step like that. So I would not be the government representative without mentioning a little bit of battle theory. Battle theory will tell you that you need to have a strategy going in, but you must modify it as you go. There's a saying that says, if you go into battle without a strategy, you're doomed. But if you go into battle with a strategy, you're also doomed. So it's something worth thinking about. I would say that, echoing on what Tom said earlier, in the organizations that I've been in, it's really been the strategists on one side and the implementers on another side. And if the strategists do come on, they do taper off. And that's a really unfortunate thing that's happening in a lot of industries, both for-profit, not-for-profit, sort of all the ones that I've seen. And so that togetherness, really, the strategists and the implementers really have to stay together throughout the entire process. And I think it would really be a huge change in how we see that gap. I'll say also that strategy is changing. And the way that we the way that we judge a successful implementation is also changing. And so it's important to look at it from the sense of these input variables changing, and then the gap continues to look different. It looks different than it did even 2 years ago. And I'll give a very, very quick example, since I know Brian asked me for some case studies. I'll say that with regarding strategy changing, at MIT Lincoln Laboratory, I work with the Satellite and Space-Based Payloads Division. And really, what we used to see is the Air Force come and they wanted these $1 billion monolithic satellites that had search-based capabilities and tons of different functions, and there were just really large gaps between their strategy portfolio. Those satellites would take 15 years to build, they would have a 10-year on-orbit lifetime, and really, if there was one critical failure, the whole mission was a failure. It was really unfortunate. And so now we see this paradigm shift in the way that the government is looking at their strategy. They're turning it now into incremental step functions. And the new technology that we have in place allows us to do that. And so I had the pleasure of being part of the Air Force's Operationally Responsive Space Satellite, or ORS-5, We call it lovingly SensorSat at Lincoln Lab. And it launched last August and is now performing on orbit nominally. But what SensorSat did was it embodied that paradigm shift. We were able to take the top 2 core technologies that its on-orbit predecessor had and create that satellite for 10 times cheaper and 10 times smaller than its on-orbit predecessor. And now we're able to take all those lessons on orbit right now and build the next round, the follow-on program to SensorSat, all in less time than its on-orbit predecessor had even been designed. So we're constantly learning from all of these experiences, and we're really changing the way that that strategy looks to us. Very, very quickly on implementation, the way that implementation is measured is completely different than it was. And I'll use a quick medical device example. One thing that impacted me pretty severely was the usability regulation. For those of you that are in medical devices, that's IEC 62366, and it's the very, very basic principle that if you're using a device that's going to help save your life, it's really important for you to know how to use it. And the scary thing about this is that this regulation of usability was not in place until 10 years ago. And so there was nothing that said that people needed to know how to use their medical devices. And now usability is the #1 thing that we consider when making medical devices. And I had a really uncomfortable learning experience where, we were building a brand new no-touch thermometer, really novel technology to be able to take your temperature and not wake up your child, basically while they were sleeping. I had a prototype on my desk, and one of my demand planners just happened to walk by, pick up the prototype, and just give me some feedback later. And that piece of feedback ended up being the single most impactful design change that we made throughout that process. And it was a really uncomfortable conversation to have with my CTO, where I said, well, the most important design change we made was actually just at the tip of our fingers. And now everything is at the tip of our fingers with Amazon reviews and cloud and all these things. And so that's what I mean when I say that implementation is completely changing, and that is now turning into sort of the most important thing that there is. So I'll end with a sort of a chapter out of Sloan's playbook. They say they really want creative solutions to common problems, and I think that's something that's really resonated with me throughout my career. And I just wanted to say thank you to all of you who have been here today. It's been a really wonderful learning experience for me, and I'm looking forward to day 2. Thank you.
Thank you. Caroline?
Hi there. So when I first spoke with you earlier, I was talking about my previous position. I now have a new position, so I'm back in Boston now 4 weeks. I'm going to give you a couple of examples from sort of both parts of my world. One of the things that my experience has been is, at least in the sort of product development workplace world, is that given a strategic direction, that people typically don't ask the right questions. And we started off today by talking about the 4 quadrants. There's the known knowns and the unknown knowns and the known unknowns. Anyway, 4 quadrants. And yes, the most challenging is probably the things that we don't know. But I also realize that most of the time I've run into situations where people don't fully recognize what they can know. And I call that sort of uninformed ignorance. It's not really willful ignorance, it's just uninformed. I'm actually my own personal case study on that, because I remember when I first discovered Palm Pilots, when everyone remembers when they first came out, and I went, oh my goodness, that's amazing, I have to get one. And my friends are looking at me going, they've been out for 2 years. And so, I would have been an early adopter had I even known such a thing existed. But I didn't. I was just uninformed. And I ran into that a couple of examples. So when I first started at my last, actually a few companies ago, they had spent a year coming up with a new process for how you would manage your supply chain. And they had been having meetings every week, and it was a big team, and they finally were just closing on this new supplier management process when I came on board. And I said, oh, well, that's interesting, and went to the library and pulled out a paper, and it said, when people start looking at this, this is what they usually develop, and here are the improvements upon that. Like, okay, you just wasted a year. You could have just looked in the literature and found out the answer and be reading a half an hour. But they didn't know to go look at the literature. And in my current position is the same thing. Is we've developed tools that analyze software architecture, and can be able to tell you where the problems are in the architecture. But the biggest challenge is people don't even know that that can be a problem. And so I think that that's actually one of those really interesting implementation challenges, and it's an interesting thing for people looking at strategic direction to think about is, okay, if I have set a strategic direction and people need to move forward, what don't they know but that can be known? How do we make sure that at least we know the things that we can know? That's it.
Thank you. Let me follow up. There was a common thread throughout that Tom kicked off in describing kind of the criticality of the way that the strategy finds its way into the implementing organization, and not just, and then even to the final comment that you made, that kind of there are things that are knowable that on paper are out there, but this doesn't happen. Well, I don't think it happens automatically, and even despite all the new techniques for more rapid iterative product development, for example, is a question, but I'll assert that I don't think it changes the general human cognitive processes for becoming aware of, developing ownership of, buying into the background, and beyond all that, forget the thing itself, adjust the regular organizational mechanisms to show respect, define the boundaries, and put people in a condition where they're going to actually do it. So what do you think?
Well, I think we need to look at first about how the strategy is delivered. And then something that I heard a lot today is it's surprising, and I was surprised actually at how conflated goals, strategy, and implementation are. And the way you deliver the so-called strategy to the implementation team really dictates what they're gonna call known, unknown, and what are the movable pieces that they can work with. Because a lot of times what you'll get is all three of them at once. Here's a goal, here's a strategy. I'd like the weight loss thing from Dr. Tang's kid over there. Losing weight ain't a strategy, man. It's a goal. What's your strategy to do it? Well, you're gonna have to start exercising or stop eating or do both. Or take some certain types of medications. But anyway, yeah.
It merits an answer, he says. You gave him an opening. Take it.
Specifically, come to my presentation tomorrow, where I describe what is a goal, what is an objective, and I describe what makes a goal and what makes an objective, and I describe the conditions under which there's clarity on that issue. Okay, enough said. I mean.
Yeah. My point though is that if you're an implementer and you want to deliver something, or you're a strategist and you want something delivered, you really need to have a two-way conversation and separate what you really want. And is that in terms of making that the goal that the team understands so that they can give you some input on how your strategy might be flawed, because the strategy is the thing that should hold the goal and the implementation together. They are not the same thing. Not in the eyes of maybe you're going to tell us that tomorrow, but not in the eyes of the implementation team, because the implementation team a lot of times has the knowledge, the ability, the freedom, and these days. As my neighbor to the left here kind of intimated, can give you formative input that will modify your strategy in profound ways. Like I'll bet the woman that picked up that thermometer was a mother, and she said, this thing beeps when it reaches temperature, and that's going to wake up the kid. Get rid of the beep, or something like that. I don't know, but so the implementation team wants that opportunity to shape the input. And if you give them the goal, the strategy, and the implementation all in one package, and you're overbearing enough, and you've got the right yes men or the wrong yes men in the right places, they'll stand up and salute and go fail. Seen it many, many times.
I would completely agree with that. I think that, to touch on your question, Brian, I think that, you know, at the end, it's human nature, right? It's a psychology question of how to best deliver that. But in the end, we all see that many people have different personalities and different motivators, and it's kind of about wrapping your message around those motivators to be able to kind of get through. And I've sat with many, many implementers that have said, well, I just wish that someone had looped me in on the strategy. And you lose a lot of time when you have to do that feedback loop to kind of adjust your strategy that should have kind of been that way from the beginning.
One of the things that was struck, you know, I was thinking from your presentation deals today, the second presentation, that you know, part of this is not only simply conveying the strategists to the strategic function, delivering a strategy, and maybe being more inclusive of the implementation, just the opposite. I think maybe in Japan we think this way too, but where, in fact, the strategy might be the emergent piece, right? So, you know, maybe that the implementation approach or the actual implementation may be emergent of all these other things, but the strategy itself and through co-creation. And so the question is, what's the ecosystem in the way the ecosystem contains that strategy development function and that implementation function working together so that you get the co-creation and the emergence. So do you have a thought? I mean, is it can you go as far as to say, fire the MBAs and is there a difference in function and a reason for that difference in function?
I don't think you need to fire the MBAs. I think you need to give
Please don't fire us.
Well, I'm not an MBA, so I can speak with impunity. I think what you need to do is give accountability on the deliverable, on the end deliverable. And that's missing in many, many cases. It's this handoff mentality. It's if you don't have any accountability to deliver it, and you have the ability to say, you just go do it, and like I said, you have the right or the wrong environment, you'll create a mess. So I think to make the strategy the emergent piece is put the accountability on both sides for both the implementation and the strategy to some degree, so that you can say, look, here's a strategy that gets us to our business goal that we think will work. Okay, implementers, what do you think? But at the end of the day, we're all going to be together when we deliver this thing. And I think that is something that works really well. I've seen that done as well, and that creates a lot different approach to your implementation team, and it creates a lot different approach to your strategy. You tend not to overcommit.
Well, I want to leave us with a thought to think about and transition out to the food and open bar to continue talking about, which is, you know, we've talked about this in this case from a practitioner point of view, the condition under which, for whatever reason, the strategy is not, I'll use a word you use, which is an important word, is not felt, right? It's not, it hasn't dug in, and it's for some reason it isn't owned by those who must implement, whether or not they were part of crafting it, but that there's conditions. So I want us to think about how do we know that? If I walked into an organization, not just as a consultant, but as a scientist, and I were to try to determine this, whether we talk about mental models or what is it in the actions and behaviors and the interactions of the implementation organization, that would be evidence of this condition of the strategic function being effective. So that's. You want to close on that? Well, no. If you want to answer, if you already know the answer, we're done. You go for it.
I think you look at who's present on the implementation team, and who's present in very simple things like whatever process you're using, agile sprint reviews or milestone reviews. Who's there? You know that, and who's listening, and how how detailed or simplified is what is being presented. Because if they're not there looking in on what's coming out, they don't have a dog in the fight. So I think that's one, not the only way, but that's certainly one way to do it.
Yes, Vic.
You raised a very key point about how would you know that the strategy is being felt if you were walking around an organization. I'll give you my own personal experience. I had an organization, very large, actually engineering organization. And this is how I discovered my strategy was being felt. I was passing by a conference room and the engineers were discussing the plan. And I overheard one engineer say, "No, that's not what Vic will say." And he went and explained what was my idea of what should be done. That's a great indicator.
Yeah. Very good. All right. With that, thank you all for a terrific day. Let's adjourn to the hall. And for those of you online, I'm sorry we can't share our food and drink with you, but we'll see you.